we look at number 1, it says for triangle PDF and triangle JKL to be congruent, which factors are needed? So basically we have to look at each one of those lines and determine if they're going to give us enough information to say that the triangles are congruent. And so remember, we can use any of those congruence theorems we learned earlier. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. Or if it's a right triangle, we can use hypotenuse leg, HL. So when we start looking at it, we got PF is marked at 14 and LJ is marked at 14. So those are already congruent. And now we need two other pieces to be able to be congruent to create the congruent triangles. So A gives us PF and JL, which are the ones that are already marked congruent, and PD and JK. Well, PD and JK, along with that, it's only going to give us two sides, which is not enough. So we can mark A out as a possibility. And so then on to B, PD is congruent to JK. So PD and JK. And DF is congruent to KL. DF and KL. So by looking at that, now we've got three sides that are congruent, which would match up with side, side, side. So B will work to prove those are congruent. All right, then number 2, for triangle ABC, congruent to triangle DEF, which statement must be true? All right, they're only giving us one item, so really what we're looking for is to determine if what they're giving us are actually corresponding parts. So angle C and angle E, if we look at those aren't even corresponding in the triangle, so those aren't going to work. So that marks A out as a possibility. And AC and DE, AC and DE, those don't correspond. DE is the long side and AC is the middle length side, so that one doesn't work. So we can mark out B as a possibility. BC congruent to FD. BC is the short side, FD is not the short side of that triangle, so that one's not going to work. They're not corresponding. Which hopefully means D is correct, otherwise we've messed up here somewhere. So AB, the long side there, congruent to DE, the long side in the other one. So those actually correspond, so those would have to be congruent for those triangles to be congruent. All right, number 3, for triangle XYZ and triangle DEF to be congruent, which statement must also be needed? Well, when we look, we got angle Z and angle E both marked at 48 degrees, so they're going to be congruent. And so angle Y congruent to angle F, and angle X congruent to angle D. So we've got all three angles marked congruent, but unfortunately that's not enough to prove that triangles are congruent. We got to have at least one side. There's no angle, angle, angle. So that possibility doesn't work. Then for B, XY is congruent to DF. So XY and DF. And then XZ and DE. XZ and DE. So there we've got an angle and two sides, but the two sides are not attached to the angle, or not on each side of the angle. So it's not side angle side, and there's no side side angle, so that one doesn't work. The next one, XY congruent to DF, XY and DF, and then YZ and FE. YZ and FE. Once again, two sides in an angle, but the angle is not included between the two sides, and there's not a side-side angle, so that one's not going to work for us. And lastly, we got XZ congruent to DE. So XZ congruent to DE. And YZ congruent to FE. So in this case, we've got two sides and an angle, and the angle is trapped in between the two sides. So that matches up with side angle side. So we'll go with D. All right. For triangle XZY and triangle PEN to be congruent, which statement must also be true? All right, now they've got one set of congruent angles, P and X are congruent. And A says angle X is congruent to angle P, which we've already got marked, and angle Z is congruent to angle N, which those aren't even corresponding, but just having two congruent angles wouldn't be enough to prove they're congruent anyway, so A is not going to work. And then B, XY is congruent to PE, so XY and PE, those actually aren't even corresponding sides, so that's not going to work. And then we've got angle Y congruent to angle E. So angle Y and angle E. So if we look at those two figures, those are not corresponding angles. So that one doesn't work. And so angle X or side XY congruent to PN. So XY and PN, and Z and E congruent to each other. So there we got two angles and one side, which would match up with angle, angle, side. So D will work. Number 5 in the diagram, triangle ABC is congruent to triangle XYZ. They're congruent, so state the measurement of YX. And so if the triangles are congruent, then we know the corresponding parts have to be the same. So really we just need to know what matches up with side YX, which would be side AB, which is 13. Alright, so in the diagram, triangle HJK and triangle XYZ are congruent. Find the measures of angle YZX and angle XYZ. So since they're congruent, the corresponding angles should be the same. So angle K is 95, so that means angle Z should be 95. Angle H is 62, so X should be 62. And then for J and Y, they're going to be whatever's left over when we take 62 and 95 away from 180. So 180 minus 157 is 23. So we got 23 for Y, which would be angle XYZ, and 95 for YZX, which would be C. Alright, so circle M is congruent to circle N. Circle M has a circumference of 56.52 feet. To the nearest tenth of a foot, state the area of circle N. So in order to find the area, we've got to have the radius. So we're going to use the circumference, which circumference is 2 pi r. And they gave us a value for that, which is 56.52. And they told us to use 3.14 for pi, so that's 2 times 3.14 times r. So if we divide by 2 times 3.14, which 2 times 3.14 is just going to be 6.28. Go ahead and multiply that out. So 56.52 divided by 6.28 is going to give us 9 for our r value. And so to find the area, We use pi r squared. So that's going to be 3.14 times 9 squared, 3.14 times 81. It's going to be 254.34, which to the nearest tenth of a degree would be D, 254.3. Number 8, state the number of sides of a dodecagon. So it's just a matter of knowing your names for the polygons here. And dodecagon is 12. Number 9, state the type of figure. So let's count the sides first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 sides makes it a nonagon. And there aren't any of the sides that if you extended them, they'd go inside the figure. So that makes it a convex nonagon, A. Number 10, state the measure in degrees of interior angle of a regular octagon. So we want to know the measure of one angle inside a regular octagon. So we use the formula n minus 2 times 180 divided by n, where n is the number of sides. And since we're looking at an octagon, our n is going to equal 8. So it's going to be 8 minus 2 times 180 divided by 8, or 6 times 180 divided by 8, and plug that into a calculator. And we get 135, which is going to be C. And number 11, what's the value of x in the quadrilateral? Well, we know there's a theorem that tells us that the angles of a quadrilateral add up to 360. So all of those angles there should add up to 360. So 75 plus 5x minus 12 plus 112 plus 2x plus 3 should equal 360. So combine our like terms. 75 minus 12 is 63, plus 112 is 175, plus 3 is 178, and then 5x plus 2x plus 7x equals 360. And it's just a matter of solving for x. So subtract 178. 7x equals 182. Divide that by 7. And we're going to get that x equals 26. Which would be A. And number 12, we're finding the value of J. And the only number value they give us is the 118 for this exterior angle. But we do know that it's an isosceles triangle because there's two sides that are marked congruent. And J is up here at what we call the vertex angle. So 118 and the angle right next to it are a linear pair, so they should add up to 180. So 180 minus 118 is going to give us 62 degrees for that base angle there. But since it's an isosceles triangle with these two sides congruent, then that means that the two base angles should be congruent. So we know the other one should be 62. And so J is going to be what's left over if we take those two 62 degree angles from 180. So 180 minus 62 minus 62 is going to equal 180 minus 124, or 56. So J is going to be 56 degrees. Alright, so state in terms of x the measure of angle M. So we want it in terms of x, so we're not actually finding a number value, we're finding a representation with x in it. And so we know that they gave us two angles, or representations of two angles. So the third angle should be whatever's left over when we take those two away from 180. So if we take 100, our angle M is going to be whatever's left when we take 180 and subtract x plus 12 and subtract 2x minus 8. So distribute those negatives to get rid of the parentheses. So M equals 180 minus x minus 12 minus 2x and plus 8. And combine our like terms. 180 minus 12 is 168. Plus 8 is 176. And negative x plus negative 2x is negative 3x. Or 176 minus 3x, which would be B. And 14, the diagonal M to K for rectangle MNKL is 48 feet long. State the length of NL. Well, since they told us it's a rectangle, we know that the diagonals have to be the same lengths. So if MK is 48, then NL has to be the same length, which is 48. (15) State the length of GK using rectangle HJKL. And so when we look at this, we know that GK is half of HK. And so if we look at the triangle that GK is a part of there, that would be a right triangle since they told us it's a rectangle. And so we can use Pythagorean's theorem, right? A squared plus B squared equals C squared. So that's going to be 12 squared plus 16 squared is going to equal HK squared. And so that's 144 plus 256 equals HK squared, or 400 equals HK squared. And then to find HK, we're going to take the square root, both sides. So 20 is going to equal our HK. Now HK is not what we're looking for, because remember we're looking for GK, which GK is half of HK, or GK is going to be half of 20, which will be 10. So 10 inches, A. And 16, parallelogram BANK is shown. Diagonals BN and AK intersect at Y. BY equals 3x plus 6, and BN equals 8x minus 4. Find BN. So we're looking at BY and BN. The relationship between those is that BY should be equal to half of BN. So if we plug those into the equation, we got 3x plus 6, the value for BY is equal to half of 8x minus 4, the value for BN. So distribute the 1/2, that's going to give us 3x plus 6 equals 4x minus 2. And then solve for x. I'm going to add the 2 over and subtract 3x, so my x's stay positive. That'll give me 8 equals x. And we're not just looking for x, we're looking for the length of BN. So we're going to take that 8 and plug it into 8x minus 4. So 8 times x, which is 8, minus 4. That's going to be 64 minus 4, or 60. Good. All right, so 17, Jimmy has 240 feet of fencing to create a square playground. What will be the area of the playground? So if we're going to fence it, we're talking about the perimeter. So he's got 240 feet for a perimeter of a square. And perimeter equals 4 times a side. And so we got a total of 240 feet equal 4s, or divide by the 4. Our side length equals 60. And so we want to find the area of that playground. Area of a square is the side squared. That's going to be 60 squared, which when we square that, that's going to be 3,600. All right, so then 18, the area of a circular pool is 327 feet squared. State the approximate diameter of the pool. I guess I wrote pond on there instead of pool. So the area is 327. We know area of a pool is pi r squared. So and they want us to use 3.14 for pi, so 327 is going to equal 3.14 times the radius squared. So by 3.14. And so we divide that out, that's going to be 104.14 equals r squared. And solve for the radius. Take the square root of both sides. So our radius is going to be 10.2. It's asking for the diameter of the pool, so we know diameter equals 2 times the radius, or 2 times 10.2 is 20.4, and so approximately that would be 20 feet. All right, so 19, circle inscribed in the square ABCD has an area of 314 centimeters squared. What is the area of the shaded region? So they're giving us the area of the circle and want to find out what the area is of these corner squares, or corner almost triangles, I guess. So in order to do that, we need to find the area of the so we need to find the area of the square so that we can subtract the area of the circle from it. And so if we can find the diameter of the circle, the diameter of the circle would represent the same length as the side of the square. So we're going to use the area, remembering the area is pi r squared. So 314 is going to equal 3.14 times the radius squared, divided by 3.14, so 100 equals r squared, square to both sides. So our radius is going to be 10. We need the diameter, which would be the same thing as the length of the side. So 2 times 10, or 20. So our side length is 20. And so the area of the square is going to be side squared, or 20 squared, which is 400. So the area of the shaded region is going to be equal to 400 minus 314. It's going to be 86 centimeters squared. Number 20, John's going to wrap 4 different colors of barrels with protective film. There are 1/4 as many yellow barrels as green barrels, 1/7 as many yellow barrels as red barrels, and 1/3 as many green barrels as blue barrels. If 1 roll of film wraps all the green barrels, how many rolls of film are needed? So we're going to relate, most of these are related to the yellow barrels. So I'm going to look at it as yellow, green, red, and blue. I'm going to call the yellow X. And there are 1/4 as many yellow as green. So that means there's 4 times as many greens, or 4x. There are 1/7 as many yellow as reds. So red's going to be 7x. And then 1/3 as many green barrels as blue barrels. So there's 3 times as many blues as greens. So 3 times 4x is going to be 12x. It tells us that one roll will do all of the greens. So one roll is going to do 4 x's. And how many total x's do we have? We add them all together. 1 plus 4 is 5, plus 7 is 12, plus another 12 is 24 x's. Divided by the amount of one roll, which will do 4x. So it gives us a total of 6 rolls needed. Alright, 21. In order to prove that triangle XYZ and triangle PQR are similar, which additional facts are needed? Well, they gave us that P is 99 degrees and X is 99 degrees, so we know that they're both congruent. And R is 48. So if its corresponding angle is congruent, then we would have 2 angles, which is enough to prove similarity, which its corresponding angle would be Z. So measure of angle Z needs to be 48. Alright, so number 22, in order to prove that triangle ATM and triangle NLX are similar, which facts are needed? Alright, so in order to prove that they are similar, so A gives us TM congruent to LX, so TM and LX, and AM congruent to NX, which just gives us 2 sides, which really isn't enough, so that one's not going to work for us. And B, angle A congruent to angle N, and angle M congruent to angle X, which gives us 2 angles, and we actually have a theorem that tells us that if you have 2 angles that are congruent, then the triangles are similar. So B will work on that one. And 23, which of these equations must be true for triangle ABC and triangle XYZ to be similar? So they're giving us proportions, so we have to make sure that the proportions are built from corresponding sides, basically, is what we're doing here. So we got AC and XZ, so AC and XZ, and BA and YZ, BA and YX. So are those corresponding, those set up corresponding? Right. So we got the long side and then the straight side, the long side and the straight side. So we're actually comparing corresponding parts. So that one should work. What we're looking for there is to make sure that they're not giving us parts that aren't going to correspond, like BC and YZ, those correspond for the next one, but BA and XZ, BA is there and XZ is the other side, so those aren't actually corresponding. So since A was already showed us the ones that were corresponding, we're good to go with that one. All right, 24 says a building has an area like the polygon shown. A similar model is built with the shortest side 2.5 centimeters. What is the length of the longest side of the model? So if the shortest side is 2.5 on the model, then we look to see, okay, the shortest side on the actual building is 5 feet. So 2.5 is comparing to 5, like the longest side of the model, which would be our X, over the longest side from the actual building, which would be the 22. So cross multiply, and we're going to get 2.5 times 22. It's going to be 55 equals 5x, and divide by 5. So we're going to get x equals 11. So that'll be B. And then 25, rectangle ABCD and WXYZ are similar. The ratio of their perimeters is 1 to 3. If the perimeter of ABCD is 24 centimeters and the area of ABCD is 35 centimeters squared, what is the area of WXYZ? So one thing we have to know is that the ratio of perimeter is 1 to 3, but if we go to area, we have to square that, because areas are the length squared. So for area, we're going to have 1 squared to 3 squared, or that's going to end up being 1 to 9. And so if the area of ABCD is 35, then we're going to have to multiply that by Alright, so when we look at it, we got 35 is the area. So 35 to x, which will be the area of the other figure, should be equal to, or the same as 1 to 9 as far as the ratios go. So we would cross multiply. We have x equals 35 times 9. Which is x equals 315. Which we don't have that answer there because I believe when I was calculating the answers, was looking at it as a ratio of 1 to 2 instead of 1 to 3. So if this was 1 to 2, then it would be 1 squared to 2 squared, which is 1 to 4, which would have given us 35 over x equals 1 over 4. Cross multiply, x equals 140. So a little mishap on my part on creating the answers there.